All right, people, let's take a look at this test review here. This is a little bit different. I'm writing on the board this time, and we'll see how this works out. All right. First of all, question number one is explain Dalton's law of partial pressures. A couple of things. Gases don't mix. And you can just add up all the pressures, add up all the gases, add up all the gas pressure to equal the total pressure. All right, so if we take a look here at number 10, that might help us with that a little bit. I mean, at number 2. So this one says the container has a total pressure of 900 millimeters of mercury, all right? And the container has 3 gases. One of them is 450 millimeters. The other gives us 200 millimeters of mercury. So what is the third gas's pressure? Well, this is just going to add up to 900. So this is 650. All right, so 650 plus what equals 900? 250. 250 millimeters of mercury. That is the pressure of the third gas. That's just Dalton's law. We talked about that. All right. I'm going to give myself some room here to do this problem. People, if something goes by too fast in the video or you think I'm talking too fast, pause it and rewind it. It's a video. All right, here we go. A dirt bike cylinder has 85 milliliters. In the original version of this, it said cc's. Well, a cubic centimeter is a milliliter, all right? So a dirt bike cylinder has this volume, and the pressure is 900, and the temperature is 363. If you look, it gives us the volume and pressure again. So this is going to be a combined gas law problem, all right? And this is the combined gas law. Combined gas law problems are before and after problems. So we're going to go right here. We're going to put our numbers for the letter. 85 milliliters is our volume. That would be 0.085 liters. And our first pressure is 900 millimeters of mercury. Okay, so our first pressure is 900 millimeters of mercury. And then the first temperature is 363 Kelvin. And that's good because we have to use Kelvin here. Now, the volume changes to only 5, so it gets really, really small. That'd be 0.005 liters. And the pressure goes up to 6,000 millimeters of mercury. What is the new temperature? Now, the hard part about a problem like this is the variables on the bottom. But we know from our middle school math that we can cross multiply numbers, correct? So I'm going to take this t, this variable we don't know, and I'm going to put it up here. Okay? So I'll move the t up here. I'm going to take 900 times 0.085, and I'm going to put it down here. So this is just cross multiplying. 900 times 0.085. So those numbers go down there. And then we can put the t up here. And now it's going to be easy to solve. We're solving for t. Take 363. We're going to put it right there because we're just doing some middle school math here. We're just cross multiplying. And then we'll take our calculator, and this is our answer. Don't forget, we've got to use these parentheses on the bottom, or your calculator will give you the wrong answer. 6,000 times 0.005 times 363 divided by parentheses 900 times 0.085 equals, close parentheses equals, I get 142 degrees Kelvin. So my answer is 142 What's it, 142? Yeah, 142 Kelvin. So this is not real because 142 Kelvin is super, super cold. So I don't know if I created this problem or something, but the answer is 142, but in reality, that's nonsense. I think you can agree. A motor doesn't get cold like that when it's running. All right. A fixed container, that means the volume doesn't change, has 2 moles of a gas, this pressure and that temperature. What is the volume? This is actually a Pivnert problem. I realize that it looks like it's in the section where we were doing PV over T, and I apologize for that. But since you're only given the numbers one time and you're given moles, it has to be Pivnert. 2 moles. N is our 2. 4 atmospheres. Our pressure is 4. So R is 0.0821. Now, if you don't understand this, when you're given atmospheres, the R has to be 0.0821. This is always on, you can always use your tables. 2 moles, the temperature is 505 and it's in Kelvin, so we're good there. And we got to find out what is the volume of this cylinder. Take the 4, put it down here. Some middle school math there. 2 times 0.0821 times 505 divided by 4 equals. I got 20.7 liters. 20.7 liters. All right, let's keep going. Number 5. Can we determine what gas that is? No. We don't know how much anything weighs. All gases act the same. The only difference is their weights, and we don't know the weights of any of those gases. All right, I'm going to choose out of these. I'm going to just do number 6. All right, number 6. Let's take a look at this problem, and we see that this problem is going to be a combined gas law problem because we're given volume and temperature and things multiple times. So P1 V1 over T1 equals P2 V2 over T2. These are our before and after gas problems. A weather balloon has a volume of 599. So our first volume is 599 liters. At STP, standard temperature, we know, is 273 Kelvin. And pressure, standard pressure. Well, since the problem is in kilopascals, we're going to give the standard pressure in kilopascals, which again is on page 1 of your tables. That's 101.3. If you look on page 1 of your table, standard pressure in kilopascals, 101.3. All right. It goes high into the atmosphere where it gets down to negative 33 Celsius. Well, our temperature has to be in Kelvin. So we would say 273 minus 33. That gives us 240 Kelvin. Got colder. The pressure drops to only 77 kilopascals. Whoops. The pressure, excuse me. Pressure drops to 77 kilopascal. What is the new volume? What is volume number 2? We're going to cross multiply. 240 is going to go up here. And we're going to get rid of this 77 by putting it down there. All right. Don't forget your parentheses or your calculator is going to give you the wrong answer. I'm going to take my calculator. Now I'm going to say 240 times 101.3 times 599 divided by parentheses 77 times 273. Close the parentheses, then it equals. Gives me 692.8 liters. 692.8 liters. 692.8. So 692.8 liters. All right, let's do a couple of these problems down here at the bottom. Let's do this PIV number 8. Do our PIV number 8 problem. All right. A sealed empty Coke bottle is laying on the dash of the car. There's only 0.02 moles of air in the bottle. The volume is 500 and the temperature is 60 Celsius. What is the pressure? PV equals N RT. 0.02 moles. N is 0.02. The volume is 500 milliliters. That's 0.5 liters. And the temperature is 60 Celsius. 60 plus 273. Don't forget, we have to add 273. The temperature has to always be in Kelvin. And then what is the pressure? All right. This problem doesn't ask you to use any particular type of pressure. So as we discussed in class, we'll give it in atmospheres. So I'll put 1 for, I won't put 1. I'll put a P there for my pressure. And I'm going to put 0.0821. That'll give me the answer in atmospheres. I'm going to use some regular old cross multiplying here. We're going to take the 0.5, put it on the bottom, and now we can solve for our P. So I'll say 0.02 times 0.0821 times 333 divided by 0.5 equals, the new pressure is 1 point, it's dark in here, kids. I'm having a hard time reading it. Let's see what it says. 1.09 atmospheres of pressure. 1.09 atmospheres. Here we go. Let's skip down here a little bit further. All right, how about number 10? Now let's skip down here. Let's do one of the harder ones. Here we go. How many grams? I'm going to end it with this one, kids. How many grams of carbon dioxide are in a 2-liter bottle at 1.4 and 360? This is going to be a PIV problem. How many grams? Well, we can only solve for moles, kids. That's what we have to do first. It's a 2-liter bottle. That's our volume. The pressure is 1.4 atmospheres, which means we have to use 0.0821 for R, and the temperature is 360. So we have to solve for this N. We are going to very simply put the 0.0821 times 360 on the bottom. We have to put that in parentheses or our calculator is going to give us the wrong answer. Order of operations. So 1.4 times 2 divided by parentheses. Whoops, look at that thing. Always messing with me. Divided by parentheses 0.0821 times 360. Close the parentheses equals. I got 0.09 moles. All right. 0.09 moles. And then it said how many grams, though, of carbon dioxide. Carbon dioxide, we know, is CO2. That's going to be 12 plus 16 plus 16. That is 44 grams per mole. So if we have 0.09 moles, 0.09 or 9% of 44 grams. So we take our answer and hit times 44 equals 4.17 grams. All right. And I'll go throw this at you too, kids. I'm not going to work this whole problem, but when you do this problem number 12, it's going to say PIV. All right. Now, 12 grams of CH4. You cannot put a 12 grams here for N. You have to put moles. So you'd be like, okay, 12 over 1 times 1 over, and we know that CH4 is 12 plus 4, 16. So this is really 0.75 moles. So for N, you would put 0.75. And then you go ahead, 200 milliliters is 0.2 liters, 233. What is the pressure? When it doesn't tell us the pressure, we default to atmospheres. So since we're going to be doing atmospheres, you look up that the R for atmospheres is 0.0821. Then you can solve for P. And I'm not going to finish that one because I know you know how to do it. Honors kids, you have an extra problem down here that the others don't have. And I'm not going to show you that one. Everybody have a great day.